Hey there guys, welcome to the third and final video for your Unit 7 review. Hopefully, you're watching this to help you for your Unit 7 test, and hopefully you don't forget that you have a Unit 7 test. But if you are watching these videos, hopefully these videos have been helpful. I know they've been kind of long, they're about 20 minutes each, so it's about an hour to watch all 3 videos, but hopefully they do help you become prepared for your test. Now, for the first section, for this problem, I'll skip one of them to kind of see how you do it. They're not as bad as the other two. The third page is probably the easiest page of all the reviews. So we'll start with the first one to solve the system of equations using the method indicated. So this one tells us to solve by graphing. So to solve by graphing, what we're going to do is we're going to say, hey, I'm going to graph. Now, I always like to start with the linear equation because linear equation is probably the easiest, because hopefully you remember how to do that from Algebra 1. So this is my x-intercept plus 2, so 1, 2. And my slope is negative 1 over 1. This negative x has an implied coefficient of negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. And I've got all my points. You will not have to graph on your test. But make sure you still know how to graph anyways. It's just a good skill to have, so we can see this. And then we're going to say, okay, well, for the quadratic equation, how am I going to graph a quadratic equation? Well, you could solve by graphing. Please, we can use our calculator. So I'm going to type in the quadratic equation. Now, you can leave it with the parentheses. A lot of times you guys will ask me, do you have to multiply it out and distribute it out or expand it out? By using FOIL or double distribute, you know, I can just type in the negative parentheses x minus 2 squared plus 6. And we can see our quadratic equation here. Now to find some points, we can do Control-T, and you can find a table that will give you set points that you may need. Now you want points that are actually on your graph. So for example, negative 2, 10 can probably fit on your graph. Negative 1, 3 will fit on the graph. 0, 2, so let's go little by little. Negative 2, negative 10. So negative 2, negative 10, negative 2, 1, 2, negative 10, 1, 2. I assume negative 10 is going to be the smallest we go. 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. The other one you had was negative 1, negative 3, negative 1, negative 3, 1, 2, 3. Then we had 0, 2, which, lucky us, 0, 2 is the point we've already used, so that's going to become an intersection point. Pretty cool. Now I have to go back to my calculator. 1, 5, 1, 1, 2, 3, 4, 5. Hopefully this is faster on your end. We can switch between screens. What else? I have 2, 6, 3, 5. 2, 6, 3, 5. 1, 2, 3, 4, 5, 6. 3, 5. 4, 2, 5, 3. 4, 2, 3, 2. 5, negative 3, 1, 2, 3. Perfect. I found my second intersection point. 5, negative 3. So here are my two intersection points. 0, 2. Here, I'll write it over. 0, 2, which is this point right here, and 5, negative 3, which was this point right here. But, what you could have done is, on your graph, press Control T to get rid of that table. You could have done menu, analyze graph, intersection, and found. Oh, to find intersection, you actually have to draw your second graph. Let me draw the second linear equation. What was your linear equation? It was negative x plus 2, I believe. So let's see. Oh, no, it is negative x plus 2. Negative x plus 2. And you could have done menu, analyze graph, intersection, find the intersection between these two, 0, 2, menu, analyze graph, intersection, find the intersection. You see there's another intersection down here. And 5, negative 3. So those are the ones we found by graphing, but you could have used your calculator to find said points. So, that was part 2 recording. So by the time you see this, all 3 parts hopefully are done processing. For the next part, it says, okay, we solved this one, so these are our answers. For this part, it says, okay, solve this using substitution. So what we're going to do, we're going to say y equals x squared plus 2x minus 8, and 2x plus y equals negative 12. Now, I'm going to solve by graphing first, and then I'll solve by substitution. So first off, you need it, no matter if you solve by substitution or if you solve by graphing, you have to get it equal to y, which just means, hey, I need to move this x to the other side, so I'm going to subtract 2x from both sides. That goes out, and that leaves you just y equals negative 2. Negative 2x. Because typically you like to write the x first and minus 12. So all I did was bring down the negative 2x and bring down that minus 12. So now I have two equations. Y equals x squared plus 2x minus 8, and y equals negative 2x minus 12. Now I'm going to solve by graphing both of them. So let's hopefully not forget these equations. So let me write them down so that I don't have to keep going back and forth between these. Okay. So I'm going to go to a new graphing page, and x squared plus 2x minus 8. Here we go. Have for the next equation, y equals negative 2x minus 12. And you can see that, oops, not meant to do that. You can see that you have an intersection here, and you actually looks like it only have one intersection. It only hits this part of the graph. I'm going to click menu, analyze graph, intersection, and you can see your intersection is negative 2, negative 8. So we know that's what our answer should be, negative 2, negative 8. So let me write that here, negative 2, negative 8. That is my answer. But I'm going to show you how to solve by using substitution. So we know what our answer should come out to be. These are the effects, by the way. So I'm going to take my two equations, set them equal to each other, because they're both equal to y. So x squared plus 2x minus 8 is equal to my other y equals equation, which is negative 2x minus 12. I'm going to get everything on one side, so let me add 2x to both sides and add 12 to both sides, and add 2x, add 12, x squared equals, oops, not equal, x plus, oops, and it's also answer. X squared plus 4x, and then 12 minus 8 is 4. 4 equals 0. And then from here you solve either using substitution, factoring, whatever you want to use. In this case, I'm going to use factoring. So I need to multiply to be 4, and I need to add to be 4, which is 2 and 2. 2 times 2 is 4, 2 plus 2 is 4. So, x plus 2 equals 0. And then, so now I'm going to say x plus 2 equals 0, minus 2, x equals negative 2. And you'll do the same thing here, which I'll write it out, but you'll still end up with x equals negative 2. Notice how you get the same x answer. That means there's really only one x answer, which is just negative 2. Or there's only one intercept, which we did find out. There was only one intercept when we graphed it on our graphing calculator. Now what we have to do is we need to find, hey, what's my y value? Well, to find your y value, you can choose either equation. I usually prefer to choose the linear equation to use it easier, and plug in this x value. So I'm going to say y is equal to negative 2 times our x value minus 12. Our x value was negative 2. Negative 2 times negative 2 is 4. 4 minus 12 is negative 8. And notice you get the same answer, negative 2, negative 8. And once again, the reason that we got the negative 2 twice is going to give us the same answer twice, which just tells us, hey, you don't have two unique x-intercepts, that is to say two different x-intercepts. You have the same x-intercept twice, which really means there's one x-intercept. So this is how to solve it using substitution, or this was how to solve it using your graphing calculator. Almost done. So number 17 through 19 wants us to calculate the discriminant. So the discriminant is at b squared minus 4ac. And we're going to use it to determine our number of solutions. So first off, what we're going to do is going to set all these equations equal to 0. So I'm going to subtract 8x from both sides. And we mentioned it on a previous video that when you rewrite it, it's important that you rewrite it in a certain order. Do not write the minus 8x at the end. You always write your x squared, your number with the x, and then the number on its own. That is to say the number without the x. So we have 5x squared minus 8x plus 9 equals 0. And this is my a, b, and c. So now I can do b squared minus 4ac. So whatever my b is, squared minus my 4 times my a times my c. My b is negative 8. My a is 5. And my c is 9. Let's move this 64 minus, actually just put it in your calculator. That way you can do it all at once. So, let me show you how you can put it in your calculator. On the calculator page, because this is important, make sure you use parentheses. Sometimes I ask you guys, how are you using parentheses? And you're like, for sure, Miss Fuentes. And then you don't use parentheses. Minus 4, your A, plus 5, and the C we had was 9. And that gives us negative 160. So this is really, really important. What I want to show you is what happens if you don't use parentheses, because sometimes you tell me yes, and then you're like, why didn't I get that? Notice you get a different answer. The parentheses do matter. You're going to get the wrong answer if you don't have the parentheses with the squared outside. And the reason this happens, by the way, is because the calculator is doing PEMDAS, so it'll do exponent first, and then whatever you get from this, it'll give the negative to it. So it's actually going to say that negative 8x squared is negative 64, which is false, because we know that negative times negative is positive, so it should be positive 64. So be careful about that. So we get negative 116. So let's switch to U. Where are you? Negative 116, which is less than 0, which means you have two imaginary solutions. And once again, this is from the lesson 7.3. So make sure you know what your discriminants are, whether it's imaginary solutions, whether it's two real solutions, or only one real solution. So now we're going to go to number 18. And in this case, we're going to do the same thing. We're going to say, hey, I want to make sure that we're equal to 0 before I start assigning my A, B, and C. And this time, I will write the 81 at the end, but because it's a number without an x, it has to go in the order of x squared, number with x, number without x. And I have my A, B, and C. And when you put that in your calculator, I showed you how to put that in your calculator, you actually, surprisingly, end up getting 0. You have a 0 equals 0 case. And this is the case of one real solution. So, and what I mean by 0 is that when you do your b squared minus 4ac, I kind of skipped through that. Your b is 36, your a is 4, your c is 81. When you put this into your calculator, that's going to give you, that's going to give you 0. It's going to give you this case. And then finally we have this one, which is already set to A, B, and C because it's already equal to 0. So I can just go straight and plug it into b squared minus 4ac, where my b is 4, my a is 1/2, and my c is negative 7. Now, for this case, it's okay for you to have a fractional value in for your discriminant. You just put it into your calculator as such with parentheses and everything, and it'll give you 30, which is greater than 0, which means you have two real solutions. And you could have calculated this on your own. 4 squared is 16. Negative 4 times 1/2 is negative 2. Negative 2 times negative 1 is 14. 14 plus 16 is 30. So you don't have to use your calculator to solve these, unless you want to avoid these really big numbers. Your last question on the review, can you believe it, we're almost done, is problem 20. Problem 20 tells us that we have a function h of x. And it says, what are the apparent solutions to this graph? Easiest question on this review. Our solutions are our x-intercepts. So we see we have an x-intercept here. So x equals 3. Now, typically I will tell you, do not eyeball it, but this problem does want you to eyeball. So we see we have a second x-intercept here, which is about negative 1.5. So this is the only time that we can kind of estimate. If you have the actual equation to this, you would want to graph it, and on your graphing calculator, use menu, analyze, graph, intercept, or not intercept, 0 to find your zeros, that is to say to find your intercepts. But in this case, just eyeball it. So it looks about negative 1.5. So those are your two x-intercepts. And ta-da! You are now done with your review. So hopefully you have most of your questions, if not all your questions to review answered. If you still have questions, feel free to stop by tutoring or ask before your Unit 7 test. Best of luck!